Hello, Keystone students. We are going to kick off chapter 3 here, focusing on patterns and looking at how we represent them algebraically. Again, a pattern is just something that's going to have some sort of repetition or some sort of rhyme or reason of why things are the way they are. And algebraically means we're going to be looking at here finding an equation to represent that. And a lot of this is going to look like y equals mx plus b, right? Most of them are going to be linear equations. Our m is our slope, which is also, when we think about our rate of change, or it's going to be whatever that value is that we're constantly changing. And this is going to be our starting point, which is going to be the zero term, or I'm going to write term zero here. Okay, so a pattern is just going to be a list of numbers or objects. And when I talk about the terms, it's just going to be each item in our pattern, right? So it's going to be the first term, the second term, the third term, and so on and so forth. We have two types that we're going to be looking at. An arithmetic sequence is going to be one that is going to be created by addition, right? And our common difference is going to be the number that we add or subtract each time. A geometric pattern is going to be created by multiplication or by division. And our common ratio is going to be the number that we multiply or divide by each time. Okay? In order for there to be a pattern, we must have either a common difference or a common ratio. Otherwise, we'd just be listing numbers with really no rhyme or reason. So we have to look for either that common difference or the common ratio. And most of the time, we're going to be looking at a difference. Our patterns are going to be created by addition or subtraction. Okay? So here's our pattern: 175, 200, 225, and 250. Right? So this is going to be our first term, our second term, our third term, and our fourth term. So the first one we want to do is we have to find our common difference or ratio. And this one, it's going to be a difference, because if we look here, we notice that each time our pattern is going to add 25. From 175 to 200 is 25. From 200 to 225 is 225, is up by 25. And then from 225 to 250 is also up 25. So this common difference here is going to take the place of our m in our equation. The next thing we want to find is our zeroth term. So again, I labeled this 175 as our first term. So the zeroth term is going to be the number that would come right before 175 if we were to rewind this pattern. So to find our b, we take our first term, which is 175 in this case, and we're going to do the opposite. So instead of adding 25, we're going to subtract 25. So our starting point, or the zeroth term, is going to be 150. And then our equation is, we can write it either y equals 25x plus 150, or you may see it as a sub n, a because it's an arithmetic sequence, and just tells us that each term is going to be labeled as n, and it's going to be 25n plus 150. Either one of those would be acceptable to do. Okay, moving on to the next one. The table below represents the depth of a water. So again, we're going to look at what's happening here each time. So from 8 to 9.25 is 1.2 is going up by 1.25. Again, we go up by 1.25, and each time we're adding 1.25 the previous number. So our slope, or the common difference, is going to be 1.25, because that's what we're going up by. our starting point, and the nice thing is it actually gives us the 0th value, which is 8. So that's going to be the b in our equation. So now what we're going to say is the depth is going to be, and I'll put d here for depth, is going to be our slope, which is 1.25 h plus 8. So at this point, go ahead and you can stop this video and move on to the next one, and then we're going to finish up our notes in the next video.